We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are Wicked Inventions. Coming up, Pottery. We reveal the craft connection between slip, firing, and credit cards. Biometrics. From blood-stained fingertips to digital iris scans, it's an amazing bio-identification science. Bulldozers. Powerful pushing and caterpillar tracks, the fascinating story and manufacture process behind this mega machine. We reveal the surprising science and amazing manufacture behind these wicked inventions. Pottery is one of the oldest human inventions, supposedly originating before the Neolithic period. But just how did crushed mammoth bones play a part in the creation of pottery?
So the term pottery generally refers to objects in clay that have been fashioned into shape and then fired or fixed to shape their form. It's plentiful, it's cheap, which makes it perfect for human exploitation.
The invention of pottery itself is shrouded in mystery. However, around the time of 25,000 BC, evidence shows findings of figurines that contained a mixture of clay with crushed mammoth bones. Today, these findings are still considered the birth of pottery.
As clay experimentation continued over time, we saw the introduction of pottery manufacturers into Japan and China. The first pots that were being made were primarily food preparation pots.
However, these early manufacturers used different methods to create their products. Their creations are separated now into three basic categories of ceramic ware. Earthenware pottery, which is the oldest and easiest method, is the darkest in colour and is usually the softest. An example of earthenware would be a flower pot. Stoneware pottery, which is strong and chip resistant. Examples of stoneware pottery would be kitchen essentials such as mugs. And porcelain, which remains the finest and most valuable variant. Porcelain is usually hard, strong, and can even be translucent.
Until the 18th century, potters around the world generally sold their products in small quantities in markets or via merchants. However, in the 18th century, British potters started to experiment with new body types, they perfected new glazes, and they started to manufacture in factories rather than selling directly to the consumer.
Towards the end of the 18th century, moulds were used to make mass quantities of consistent product so that the consumer could be assured of the look of this piece before purchase. Pottery is still made across the world today, following the traits used by potters across the centuries, making it a truly wicked invention. Rob Bibby creates hand-thrown pottery masterpieces from his workshop in Northamptonshire, England.
I've been a potter most of my adult life. I'm now 71 and I'm still doing it from my workshop in Wood Newton, and I run a couple of pottery classes for local people as well.
The production of a clay teapot begins with, you've guessed it, clay. White, wet earthen clay is prepared by kneading it thoroughly. The clay is mixed with paper pulp to give it strength. The kneading continues until all of the streaks are blended and it is a consistent grey colour. Clay can be reused and recycled, so this stage is key for removing any unwanted lumpy bits. Clay can be reshaped and reused often. It can be kept damp by storing it in a sealed plastic bag and can be stored for 2 weeks without the quality being affected. Next up is the throwing stage. Throwing is essentially what happens at the potter's wheel. Clay is put onto the centre of the wheel and then the potter can begin his delicate art of throwing. He works the spinning clay using his hands, but also can use different tools to create certain shapes and smoothness. Here, he's using a credit card that is ideal for shaping the clay in a consistent way. Through the years of practice and a few wobbly pots, an experienced potter knows exactly when the clay is ready to be shaped when on the wheel.
It takes time and practice before you get good and confident at it. I think a potter gets better all your life. You can carry on getting more confident about throwing.
He uses a damp sponge to keep the clay wet and malleable. When happy with the shape, a cheese wire is used to cleanly remove the pot from the wheel in one swift motion. For the lid and the spout, the general technique is the same, just the shaping is different. Spouts are made by making a cone shape. The tip of the spout needs to be nice and thin so that the tea doesn't dribble. If you've ever had a teapot that dribbles tea as you pour, it's most likely because the spout tip is too thick. Of course, this is a very delicate art, as making the tip too thin will most probably cause breakages further down the line. This pot could do with a steady base that won't make it wobble. For this, a foot ring is formed that will add stability. This is achieved by trimming the pot with a turning tool. Slowly but surely, the foot ring takes shape. From here, the pot is stamped with the all-important seal of approval. Of course, with everything being made by hand, pottery and throwing is never an exact science. No pot is ever the same, and trial and error can play a big part in a pot's creation. Here, our potter is measuring up the lids and tidying their edges with cutting tools so that they can better fit their pots. He also pushes a hole through each lid so that they can release the steam of the delicious hot tea they will soon hold. The teapot itself can also be made bigger for the lids to fit. Slight and careful adjustments are made by trimming away just millimeters at a time until the lid can fit snugly in place. Perfect. The spout, which has had a little time to dry, is then cut at an angle to fit the pot. The potter then places it on the pot and marks out where it should sit. In the centre of this area, he punctures holes into the clay of the teapot so that it can catch the tea leaves as the tea passes through the spout. To ensure the spout stays firmly in place, grooves are marked both into the pot and the spout itself. This basically gives it all a bit more grip to stick.
When you're joining bits of clay, so for example a teapot spout or a handle, it's a good idea to score the surface of the clay and dig in a certain amount of slip, which is basically liquid clay, and you use those like a sort of glue, and you dig them into the surface of the clay, scoring both contact points before you actually join on the spout, for example.
The forming of the teapot is almost complete. Just a few finishing touches and embellishments are made now, including this rather fancy handle. With this complete, it's time for the pot to take its first trip to the kiln. The kiln will harden the clay using intense heat, totally drying it out. Once the kiln has finished working its magic, the painting process can begin. This really is an art, as we can see by this elegant design that our potter seems to be able to achieve almost instinctively. Fancy. When he's happy with his paint job, the pot is dipped in a gloss emulsion. Although it looks like it's covering up his carefully painted design, just wait and see what happens in a moment. The teapot is placed in the kiln again and heated once more. The heat in the kiln will set the special gloss and cause it to become transparent, sealing the design. And look at that, an amazingly shiny pot full of colour and handcrafted skill. With a final quality check complete, the pot is ready to pour that perfect cup of tea.
You get a lot of satisfaction out of making things in clay, and also out of using handmade things. People like that.
Pottery, a timeless, wicked invention. Safety and security have never been so important in our ever-growing digital world. Most security involves keys and codes. This might sound safe, but if they fall into the wrong hands, then your whole digital world can be unlocked and stolen. What about another system? Think of the phone that can be unlocked by a scan of your finger. Or the automatic passport controls at airports. These are using biometrics, which is using your own unique characteristics to verify who you are. It might sound a space-age concept, but its origins date back to the dawn of man.
We could argue that biometrics started even as early as cave paintings, where there are handprints on the paintings that suggest that this was a mark of saying, this is my painting, this is I who did it. However, in 500 BC, the Babylonians were known to be taking thumbprints to record transactions. Their thumbprints would be in clay tablets. We have these and we can see these, so we can know that in that manner, Babylonians were working out that this is unique enough to record a transaction and say, this is me.
The Babylonian idea of using fingerprints to identify a person was really taken seriously as a scientific method for identification, with its use in the pursuit of criminals at the end of the 19th century. In 1892, police in Argentina identified a murderer by the bloody fingerprints they left at the scene of the crime. And by 1901, a fingerprint bureau had been set up by the British police at the world-famous Scotland Yard. With fingerprints unwittingly left on glass, in stains and other objects around a location, it was to become a major tool in detecting criminals.
It was only in the late 1800s that fingerprints were considered valid for police work, because it was only in the mid-1800s that people started to work out what specific characteristics of fingerprints could actually be used to uniquely identify one individual from another. For example, do we take one fingerprint? Do we take all 10 fingerprints? And how do you deal with it? What are the particular, what's called minutiae, i.e. the particular parts of the fingerprints, where do all the ridges whirl, and how do you choose which points to pick that creates an index for that person that is unique, and as well as repeatable to present an index that is different, not by just taking different parts of the fingerprint.
The skin covering your fingers is very different to that which covers the rest of your body. Lots of tiny lines called ridges cover all of your palms and fingers and also the soles of your feet and your toes, and these are called friction ridge skin. These ridges help us to grip things and helps our body to cool down when we are too hot by sweating. These ridges can have lots of characteristics, such as breaks and bends, and are usually unique to each individual. Even identical twins don't share the same prints, and the arrangement of the ridges and their unique properties is what is used to make an identification. While ink prints used to be the messy way to check your finger identity, today the use of digital cameras and scanners have led to fingerprint scanning, where a picture can be taken of your print and the results compared to a database. The only problem with these devices is that they can be cheated by a very good copy of someone else's print, or, if you're particularly nasty, the person's actual finger, even if you don't have the rest of them. But scientists have come up with ways to make the scanners even more sophisticated.
A new improvement to fingerprint scanners is to scan deep inside the finger. By using red light, you can see inside the body because red light is transmitted through the body. With this, you can then see inside the body and see the veins inside the body. This is actually very specific and unique to an individual. If you combine the fingerprint and the veins and capillaries inside a body, you can then see that the person is A, alive, and B, has the right characteristics, both externally and internally. This also requires that the finger be actually connected to the body, because the blood is needed to fill the capillaries in order that they show up on the scan. It's much, much harder to fake than a traditional fingerprint scanner, which relies purely on electrical contact and ridges on the fingers.
Fingers can get damaged, and the scanning surfaces can become dirty and unreliable. So in the 1990s, another biometric identification method was pioneered: iris scanning. The iris is the coloured ring of muscle that opens and shuts the pupil of the eye. The coloured pattern of our irises is determined genetically, and it comes from a pigment called melanin. More melanin gives you browner eyes, and less produces bluer eyes. These patterns are unique to each person, and when scanned with a combination of normal and infrared light, around 240 different characteristics can be identified, which are turned into a simple 512-digit number that can be assigned to an individual.
Iris scanners are more expensive than fingerprint scanners, which is why you find fingerprint scanners on phones, but you do not find iris scanners. The detection needed is a relatively high-end camera and be able to compare to a database to make sure it is exactly you.
With brain and heart activity being touted as the next breakthrough in biometric identification technology, it seems that biometrics is going to keep on being a wicked invention. Can we turn a flatbed scanner into a digital camera? We're going to need some black foam board, some duct tape, an old flatbed scanner, a craft knife, a magnifying glass, and a ruler. To begin, we create a box out of the black foam. We then create another box a little larger than the first, and make an end plate for the larger box with a hole cut out to allow for attaching the magnifying glass. We remove the top of the flatbed scanner and attach another piece of board together with the boxes that create our flatbed scanner camera. After careful positioning and a few attempts to adjust our magnifying glass lenses to maintain focus, we take a scan, or should we say, picture. And there we go, a nearly perfect image. At the heart of the scanner is a CCD, also known as a charge-coupled device. The CCD is mounted on an arm called the scan head and is made up of a collection of tiny light-sensitive diodes which convert photons or light into electrons or an electrical charge, which are used to create the image of a scanned document, or in our case, a person. CCDs are found in most digital cameras, and this is the secret to how our DIY camera can work. The magnifying glass acts as the lens, focusing the light onto the scanner's surface, so as the scan head moves over the glass, our image is revealed. Can we turn a flatbed scanner into a digital camera? Yes, we can. Wicked challenge smashed. A bulldozer is equipped with a substantial metal plate used to push large quantities of rubble during construction. But just how were they introduced?
Bulldozers have always been used. They might not have gone by the name bulldozer, but something similar always has. Traditionally, they'd have had maybe a team of mules pulling a frame with a metal blade on the front, and you would by hand dump some dirt onto a surface you were covering or resurfacing, a road, a path, a gully, and the cart would be driven across it, and the blade would disperse whatever you were covering it with equally in perfect distribution.
These first types of agricultural machines were primarily used to plough fields. This need to traverse muddy terrain led to the development of caterpillar tracks, which then went on to be the foundation of the armoured tank in World War I.
At that time, we started to see the evolution of things like traction engines, steam-powered tractors, big heavy machinery being used in other areas, and the natural kind of development was to fit a blade to these. So all of a sudden you got the idea of a bulldozer blade being placed onto a steam-driven and eventually a diesel-driven engine which would work on any surface, laying its own tracks.
In 1923, James Cummings and J.L. McLeod made the first designs for the bulldozer. A year later, the pair were issued the US patent for an attachment for tractors, which is still regarded as the creation of the bulldozer. Over time, we have seen the introduction of different components that have led to the versatile success of the bulldozer.
From its humble beginnings as something pulled with a blade by mule teams, the evolution of steam power, diesel engines and caterpillar tracks, the two came together and we had the bulldozer.
From quarries to roads, the bulldozer really is a wicked invention, but just how are they made? If you need a lot of earth moving, then only a bulldozer will do. These track machines can push several tons of mud, gravel, sand, or pretty much anything with ease. In America, Case Construction Equipment has been producing bulldozers since the 1950s, and their current M-series fleet of machines work on building sites around the world.
Here in Burlington, Iowa, we have the design team here on site, we have the product validation, we have a proving grounds down the road. We're able to produce the product very efficiently.
All the raw materials needed to build a bulldozer are imported into the factory. This includes a lot of steel plating, which comes in 15 different thicknesses that range from 1.5mm to 20mm. These plates will eventually become the chassis of the bulldozer, but first they must be cut out. This involves drawing the component shapes onto the plates using a laser that is 5,000 times hotter than the sun. The laser traces out each part using computer design, first by punching through a plate and then by using the laser's sheer power to accurately cut out the chassis components. This can take up to 12 hours to complete, so there are several machines all working at the same time to create the necessary components. Once the laser has performed its operation, the chassis parts can be pushed out, leaving what looks a bit like an industrial-sized stencil. This process consumes about 500,000 kilograms of steel each year to produce the bulldozers, so every step is taken to reduce waste. This means the stencil can now be sent away to be recycled.
We practice very green manufacturing. We have a zero landfill target, and if you walk through our facilities, you will see that type of recycling activity going on.
The chassis parts are now taken away to be prepared, as the laser can cut so precisely that it leaves very sharp edges. A technician uses a grinder to smooth down every edge that has been cut, making it safe to handle in the coming stages. Next, these large cut-out components are lifted by cranes into a jig, which holds them in the correct place for each major section of the chassis. This jig can move and rotate, which allows easy access for the welding machine. This is another process controlled by computers, so when the operator begins the program, the jig moves into a sheltered area so that the workers do not need to worry about the bright light emitted by the welding process.
A lot of our parts are made right here in-house, as well as tested right down the road at our proving grounds.
Once the chassis has been welded together, it moves on to the paint preparation stage of the manufacturing process. Here, the surface of the metal is blasted away using tiny particles of sand that are fired at the chassis at high speeds. The result is a smooth, clean layer of metal, which will take paint easily. This means the chassis can begin the painting process to take on its bright yellow colour. After being allowed to dry, the chassis is taken to the main assembly line. This is where each of the main bulldozer sections come together to be assembled into a fully functioning bulldozer. The first stage is to prepare the chassis by installing all the electrical wires and hydraulic lines that will make the bulldozer function. The engine can then be mounted into the chassis too. A large crane picks this up from a transportation trolley and an engineer delicately guides it into the engine bay. Next, the cab can be mounted. As this houses all the controls for the vehicle, it is a very complex piece and it is created on its own assembly line. The cab is lowered so it is about 1 foot above the chassis. This allows the engineers to connect all the control cables to the computers inside. Once the connections have been made, the cab is lowered all the way and secured. The tracks are fitted by laying the long segments out along each side of the bulldozer. A crane then lifts one end of the track upwards and along the top of where it needs to go. When the start and end of the track line up, the crane lowers them together and the track ends are joined. Now the part that transforms a vehicle into a bulldozer is installed, the blade. This includes the powerful hydraulic piston that will raise, lower and shake the blade, giving the operator good control over what they are moving around. Finally, software is loaded onto the internal computers and the various systems within the bulldozer are filled with the right fluids. After a quick test to make sure all the systems can operate together, the machine is sent to the proving grounds. There's no better place to test a bulldozer than this. The large muddy area is where each bulldozer undergoes up to 40 hours of testing. There is plenty of mud to move around and put stress onto the machine, making sure it won't fail even under extreme use. If it passes here, it will work anywhere.
The process, start to finish, would be probably about 2 days.
After a quick clean and sign off, the bulldozer can be shipped to construction sites to start work. The bulldozer, truly a wicked invention. So, there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing backgrounds. Pottery, biometrics and bulldozers. All wicked inventions.